Hello, I'm Charlie Riggins with Pye-Barker, and if you've spent any time around pumps, compressors, blowers, vacuum systems, hydraulic equipment, or process machinery, you already know one thing. Small details can create very large problems. A missed oil change can shorten the life of a vacuum pump. The wrong airflow velocity can turn a dust collection duct into a safety hazard. And a handful of extra hydraulic connections can create leaks that waste fluid, energy, and maintenance hours. We'll look at maintenance practices for rotary vane vacuum pumps, the importance of transport velocity in dust collection systems, and a smarter approach to eliminating micro leaks in hydraulic equipment. Let's get started. Rotary vane vacuum pumps are essential across industries, from packaging and plastics to chemical processing. Their reliability, however, depends on disciplined maintenance practices that safeguard performance and extend service life. Oil management is the foundation of pump care. Operators must check oil levels regularly, replace oil at recommended intervals, and use the correct grade to ensure proper lubrication and cooling. Neglecting oil changes can lead to overheating, contamination, and premature wear. Filter replacement is equally important. Inlet filters protect pumps from dust and debris, while exhaust filters prevent oil mist from escaping. Routine inspection and timely replacement of these filters help maintain efficiency and environmental compliance. Technicians are also advised to monitor vane condition carefully. Worn or damaged vanes reduce vacuum performance and can cause costly failures. By checking vane wear during scheduled service, operators can replace parts before breakdowns occur. Leak detection is another priority. Even small leaks compromise vacuum levels and force pumps to work harder, increasing energy use and wear. Regular leak checks ensure stable performance and lower operating costs. Preventive maintenance schedules tie all of these practices together. Documenting service intervals, monitoring performance data, and training staff contribute to reduced downtime and improved reliability. Rotary vane vacuum pumps deliver dependable performance only when maintained with discipline, through oil care, filter management, vane monitoring, and leak prevention. Now, vacuum pumps are not the only systems where a small engineering detail can affect an entire operation. Our second story moves from vacuum performance to air movement, and specifically to one of the most important design decisions in an industrial dust collection system. That decision is transport velocity. In industrial environments, dust collection systems are critical for both safety and efficiency, but their performance depends on one key factor: proper transport velocity selection. When velocity is too low, dust settles in ducts, creating blockages, fire hazards, and costly downtime. When velocity is too high, systems waste energy, accelerate wear, and increase operating costs. The challenge is finding the balance that ensures dust is carried effectively without overloading the system. Experts emphasize that transport velocity must be matched to the type of material being conveyed. Fine powders, fibrous particles, and heavy dusts each require different airflow rates. By carefully calculating velocity, engineers can design systems that maintain compliance, protect workers, and extend equipment life. Modern solutions also integrate digital monitoring and airflow controls, allowing operators to adjust performance in real time. This not only improves reliability, but also supports sustainability by reducing unnecessary energy consumption. Dust collection system design is not just about equipment, it's about precision engineering. Proper transport velocity ensures safe operations, regulatory compliance, and long-term efficiency. That same systems thinking approach applies to our final story. In dust collection, unnecessary pressure loss and poor airflow design create waste. In hydraulic systems, unnecessary fittings, valves, and connections create another kind of problem: more places for fluid to escape. And as most maintenance teams know, a small hydraulic leak rarely stays small forever. Micro leaks may seem small, but in hydraulic systems, they create big problems, from wasted energy and fluid loss to safety hazards and costly downtime. For years, operators have battled these leaks with patchwork fixes, but now a smarter approach is emerging: consolidated hydraulic flow control blocks. Instead of relying on multiple valves, fittings, and connections, each a potential leak point, consolidated blocks integrate these functions into a single, compact unit. By reducing the number of joints and seals, plants dramatically cut the risk of micro leaks. The benefits go beyond reliability. Consolidated blocks simplify installation, streamline maintenance, and improve overall system efficiency. They also enhance safety by minimizing exposure to high-pressure leaks while supporting sustainability goals through reduced fluid waste. Industries such as manufacturing, energy, and heavy equipment are already seeing results. Operators report fewer shutdowns, lower operating costs, and longer equipment life. In short, upgrading to consolidated flow control blocks is proving to be a practical, forward-thinking investment. Eliminating micro leaks isn't just about maintenance, it's about smarter design. Consolidated hydraulic blocks deliver reliability, efficiency, and safety in one solution. So let's bring these three stories together. Rotary vane vacuum pump maintenance, dust collection transport velocity, and consolidated hydraulic flow control blocks may sound like very different topics, but they all point to the same lesson. Reliable industrial performance depends on taking care of the entire system. With a vacuum pump, that means managing oil, filters, vanes, and leaks before performance begins to decline. With a dust collection system, it means selecting the right transport velocity to prevent buildup without wasting energy or wearing out the ductwork. And with hydraulic equipment, it means reducing unnecessary connections and designing out potential leak points wherever possible. In every case, the goal is the same: keep production running, protect employees, reduce waste, control operating costs, and extend equipment life. Because nobody has time for surprises when it comes to critical equipment. I'm Charlie Riggins with Pye-Barker, and thanks for spending a few minutes with me. For more industrial news, practical insights, and support for pumps, compressors, blowers, and vacuum systems across Georgia and Florida, visit pyebarker.com. Until next time, stay safe, stay productive, and keep those systems running.